All right, guys, we're going to get started with order of operations. I don't believe we talked about order of operations last class. Did we talk about order of operations last class? Do you guys recall? No? All right, so we'll go ahead and start with that, order of operations. Now, for this one, guys, let me see here. Order of operations. Now, this is what we use to simplify expressions, okay? Now, the acronym, there's an acronym that goes along with this, or mnemonic device, I should say, that goes along with it. So you can remember, no, it is not my dear Aunt Sally. Dear Aunt Sally has been dead, guys, okay? We've been using dear Aunt Sally for too long. She's dead, okay? So it's PEMDAS. The acronym is PEMDAS, okay? So this mnemonic device here that we use to simplify using order of operations starts off with the parentheses, guys. Parentheses. That's what you start with, the parentheses, as well as the square brackets. The braces are in there too, square brackets. And then every once in a while, you do see the fraction bars. Like if you have something like this, A over B, the fractions, you want to work on simplifying those first. So the grouping symbols, the parentheses, the brackets, you want to do those first. And then you move on to the exponents. Remember, I like questions, guys. Drop your questions in the chat box, okay? So the exponents we're talking about are things like 3 squared, as well as the radicals, the roots. When we talk about radicals, we're looking at the square root of 9, okay? So simplify the parentheses, the grouping symbols, then you simplify the exponents or the radicals. Now here's where the problem is. When we get to multiplication and division, for multiplication and division, guys, you have to be careful. If you have both multiplication and division in a problem, you work it out from left to right, just like you're reading a book, okay? Left to right, just like you're reading a book. For example, if I were to give you 8 divided by 2 times 4, okay? Even though multiplication comes before division, you don't want to do 2 times 4 and then take 8 and divide it by 8. No, you want to work it out from left to right, guys. So you would want to do the 8 divided by 2 first, which gives you 4, and then 4 times 4 gives you 16. So if you encounter a problem where you have both division and multiplication, you work it out from left to right. Now, for this one right here, guys, very straight to the point, but you gotta be careful. So the next part of this has to do with addition, subtraction, very similar to multiplication and division. If you encounter both multiplication, division in a problem, you want to work it out from left to right, just like you're reading. So guys, be very careful with this, okay? Now, I am going to go ahead and get started with some example problems. Remember, this is being recorded. So if you're just coming in and you're missing something, the link will be sent to you later on. You can always watch it at your leisure. And if I'm moving too fast for you, you can even slow down the speed of the video, guys, when you go on YouTube. Okay, so here's the first example, guys. Let's say we have -5 plus -3 times 8. By the way, your calculators are capable of doing order of operations, so you could actually type this into the calculator and let the calculator do it for you. So on this one right here, I want to do the multiplication first. -3 times 8 is -24. So now that I've multiplied, I can then proceed to adding the -5 and the -24, which gives me a -29. Straightforward, very easy problem. Any questions on this one, guys? Remember, I like questions. Drop your questions in the chat box. Okay, so now let's go ahead and look at something that's a little bit more challenging. Okay, problem number 2, I've got 6 times 3 minus 5 to the 3rd power, minus 2 times 1 minus 3 to the 3rd power, I will be giving you some where you can work them out on your own. You're welcome to try working these out on your own as I go along, guys, to see if you can come up with the correct answer. By the way, many of these questions, you will see them on the assignment when you go on to do your work, okay? So guys, here we go. Order of operation says, do what's inside the parentheses first. So 3 minus 5 gives you a -2. There we go. So we're going to go over here. 1 minus 3. That gives us a -2 as well. Next, order of operation says, do the exponents. -2 to the third. I'm just going to go to the side and do this, guys. -2 to the third means you're multiplying -2 by itself 3 times. -2 times -2 times -2 gives you -8. And here it is again. This is going to turn out to be a -8. Now, oh, I forgot my negative here. Let me fill that in. Okay, so guys, we're going to go ahead and multiply. So when we multiply here, we get -48. Now, be careful with this next part. When you're multiplying over here, you are multiplying -2 times -8. So that's going to give you a +16. And then you want to add them together. So this is going to give you a -32. All right, guys. Questions? All right, I'm going to let you try the next one on your own. Let's see how well you do with this. Remember, you guys have the calculators that can do order of operations. So make sure, guys, you try these on your calculators. Hopefully you have a good scientific calculator with you, and you can go ahead and try it on the calculator as well. Graphing calculators work too, but if this is your last math class, as it is for many of you, you don't want to go and purchase a graphing calculator now, okay? They're so expensive, and if you're not moving on to the high level math courses, you can just get by with a basic scientific calculator. All right, guys, go ahead and give this one a try. Let's see what you guys end up with. What kind of solution are you going to get for this one? All right, give it a try, guys. Let's see what you come up with. All right, how you guys doing? You got an answer yet? What is the attendance code? Oh, let me go ahead and type it for you. 2430. Oh, I didn't send it. Shazam. There we go. Oh, I sent it to just Gina. Let me send it to everybody. 2430. There you go, guys. Everybody should have it. Don't forget to go on Blackboard to do it. What'd you guys get for the answer? Nobody? Okay, I got 45. Okay. Is the answer 45? All right, guys. So I am going to go ahead and start it. Now, for this one, there's no parentheses, so you want to go straight to the exponent. So you do 8 squared, that's 64. Keep the 16, bring the 16 down. Then you do, can you say the code again? It's in the chat box. It's 2430, I think. Okay, 2 squared is 4. I'm going to bring down the times 4. Now, guys, notice we have both division and multiplication right here. So you want to go ahead and work it out from left to right. So you do 16 divided by 4, which gives you 4, and then you'll be left with 4 times 4. You do the 4 times 4, that gives you 16. And then 64 minus 14, minus 16 gives you 48. And then 48 minus 3 leaves you with 45. And there you are, guys. Just like that. Okay, any questions? Okay, so the question you should ask yourself is this, guys. When we meet on the 10th of September, I think that's when we meet first, and we take that first test, because these questions are going to appear on the test, are you going to be able to do it? If you get one like this on the test, will you be able to figure out the answer? If you cannot figure it out, if you think you're going to have an issue with it, you need to ask a question or two. Either you can ask me to do another problem similar to it, or you could go ahead and ask me to clarify something in this particular problem for you. All right, remember I like questions. Drop your questions in the chat box. All right, guys, so here comes number 4. Now, number 4 has some brackets in there. It is 30 divided by bracket 5 squared divided by 7 minus 12. And then bracket, close out that bracket, guys, minus a negative 9. So for this one right here, you want to go inside the grouping symbol. In this case here, the brackets. You want to do 5 squared, that's going to give you 25. Do what's inside the parentheses, 7 minus 12, that gives you a negative 5. Close up the bracket. Now, over here on the right side, you have a negative, not side, on the right of the problem, towards the end, you have minus a negative. Minus a negative becomes a positive, guys. So notice I'm putting that positive 9 there. Now, we're going to continue working inside the brackets. 25 divided by negative 5 is a negative 5. And then we want to go ahead and do 30 divided by negative 5, which is a negative 6. Negative 6 plus 9 is equal to positive 3. Now, guys, if you're typing this into your calculator for the brackets, don't use the brackets. Use parentheses for the brackets. Hold on, guys. Hold on. Guys, this is working from home. Shazam. All right, so let's see, where was I? I forgot what I was saying. What was I saying? Oh, the calculator, guys. If you're typing a problem like this with your calculator, don't use the brackets. Instead, you want to use the parentheses. It's easier to use the parentheses on the calculator than it is to use the brackets. So just be careful when you're typing this into your calculator. I was a few minutes late this evening. Let me see here. May I please have the for the, yeah, it's in the chat box. It's 24:30, okay? So guys, let's see here. Here's one of the problems you're going to encounter while going through the assignments. It says cube negative 2 and then subtract subtract this from negative 10. Now, first, they have a drop-down menu with how they want this expressed, and then they want you to go ahead and actually do it to come up with the correct answer. So when they say to cube negative 2, that means that you got to take the negative 2 and raise it to the 3rd power. Now, whatever this answer turns out to be, you have to subtract this, okay? Subtract the negative 2 cubed from negative 10. So since you're subtracting the negative 2 cubed from negative 10, you want to make sure the negative 10, guys, goes first. So this is what the expression turns out to be, okay? So guys, check it and see if you have any questions about this. You are going to see a problem like this on the assignment. I'm not sure if it's in the quiz or the test, but there is a problem like this. You will see it on the assignments. Okay, so now we got to work it out and figure out the answer. I want you guys to try it and tell me what the answer is. You guys give it a try. What's the answer for this one? I am trying to get on here so I can go and check to see where this problem is at in your assignments, okay? You guys try it and type the answer in the chat box. Let's see what you guys come up with. Guys, if you have yet to log on to my math lab, please do so as soon as possible. Remember, you can get the first 2 weeks, the first 14 days for free. You do not have to have the access code during the first 2 weeks. All right, I'm checking on that problem for you guys. I know it's somewhere in there. Not quite sure. Okay, still checking. But you know what? Let me see what you guys got for the answer. Let's see. What do you have? All right. -2, -2. Oh, everybody's got -2. All right. It is -2, guys. Remember, you can also type these into your calculators. You want to go ahead and cube that -2, which gives you a -8. Minus a negative becomes a +8. So then -10 plus 8 becomes -2. So you guys are correct. Very good. All right, guys. So basically, that's the end of order of operations. Unless, of course, you want me to do an additional example if you guys don't feel comfortable with this. I believe there's going to be 3 of these type of questions on the test. That was from lesson 5 too, guys. So this is probably in homework number 1.
Can you do an order of operations with fractions? With
fractions. Is there one in the assignment?
Yeah, I went ahead and did 5.3 and 5.2, and they did like order of operations, like dividing like 2 mixed numbers.
Oh, okay, okay. That's for later on. Okay, we're going to go over that. That's not necessarily part of the order of operations. That's for another section later on. So we'll go ahead and do that, okay?
Okay.
All right. Anybody else? Okay, guys. So then let me go ahead and move on to what I just mentioned to her, which is the next section, which is lesson 5.3. And in lesson 5.3, this is where we encounter the rational numbers. The rational numbers, guys, AKA the fractions. This is where we're going to start adding, subtracting, multiplying, dividing these fractions, okay? That's a nice euphemism for fractions. Rational numbers is just fractions, okay, guys? So we're going to start off at the top with converting, how to convert a mixed fraction. Mixed fraction. By the way, a mixed fraction consists of a whole number and a fraction to an improper fraction. We're going to be doing this a lot, so I want you guys to be comfortable with converting a mixed fraction to an improper fraction. By the way, when we talk about an improper fraction, we're looking at a top-heavy fraction, which means the numerator is larger than the denominator. So right here, guys, I have a mixed fraction. This is a mixed fraction, okay? I am going to convert it to an improper fraction. So to convert it to an improper fraction, I'm going to take the denominator. You know what? Let me use a different denominator here because that's going to be a bit ambiguous there. Okay, so to change this one to an improper fraction, I'm going to take the denominator, which is 2, multiplied by the whole number, which is 3. Add the numerator, that's 1. All of this is going to go over 2. So now you do the 2 times 3 plus 1, that's going to give you 7, and then keep the denominator, guys. So 3.5 as an improper fraction becomes 7/2. So questions about this, guys? And you can do it in reverse. So let's go ahead and do it in reverse now. For the reverse of this time you are given an improper fraction, such as 23/5, okay? And you have to convert it to a mixed fraction. So you would want to grab your calculator and divide 23 by 5. When you divide 23 by 5, guys, the whole number part is going to be 4. The whole number part is 4. Because 4 times 5 is 20. And then what is left over? 20 from 23 leaves you with 3 out of 5. Now, if that didn't make sense to you, I am going to go ahead and do the long fraction, okay? So 5 goes into 23. How many times? 4 times. 4 times 5 is 20. You subtract, you're left with 3. The remainder is 3. So your whole number is 4. The remainder is the 3. That's the numerator of the fraction. And of course, this is all of 5, guys. So that's why 23/5 becomes 4 3/5. Any questions, guys? Okay, perfect. Now, I'm coming up to that question that was asked. So next we are going to multiply fractions. We're going to multiply fractions. Now, when it comes to multiplying fractions, guys, remember, it's best to cross simplify first, if possible. Cross simplify if it's possible. Sometimes it's not. Let me write this down. If possible, cross simplify. If it's not, that is okay. Then you want to multiply, if it's not possible, multiply across, multiply straight across. And then don't forget, for these problems, especially on My Math Lab, guys, if a fraction needs to be reduced, you must reduce the fraction, reduce or simplify the fraction if possible, okay? You don't have to be told to do so. Earlier, my previous class from you guys, I had one young lady who typed in an answer and she did not simplify the fractions. The computer marked her wrong. And so she said, I didn't know how to do the problem. And all it was, she needed to simplify the fractions and she got the correct answer. So guys, make sure you are simplifying your fractions, okay? So here's an example of multiplying two fractions. When you're multiplying two fractions, once again, it's best to try and cross simplify first, okay? Now, when we talk about cross simplify, we're looking at this, guys, okay? Cross simplify, not cross multiply, cross simplify. Simplify means to reduce, okay? So in this particular problem, both 4 and 2 are divisible by 2. So 2 goes into 2 once, 2 goes into 4 2 times. You're going to do the same thing with the 3 and the 9. 3 goes into 3 once, 3 goes into 9 3 times. And then multiply straight across. 1 times 3 is 3. 1 times 2 is 2. Now notice I did not mention the negatives. Now why didn't I mention the negatives? Because I have a negative times another negative, and that's going to become a positive. So the answer turns out to be a positive, guys. By the way, this one right here is on improper fraction. Now, unless they tell you to convert it to a mixed fraction, where you would have 1 and 1/2, don't do it, guys. Just leave it as an improper fraction. By the way, on My Math Lab, it's easier to type in an improper fraction than it is to type in a mixed fraction. So unless they specifically tell you convert it to a mixed fraction, just leave it as an improper fraction. All right, so now I'm ready to get to that one question. So here it is. We're multiplying, guys, 3 3/4. This is the type of question you're going to see on the test. Times 1 3/5. So on this one right here, guys, you're multiplying two mixed fractions. So the first thing you have to do is to convert them to improper fractions. That's why I had to go over that with you guys earlier, converting from one form to the next, because here we go. We have to convert these in order to be able to multiply them. So in this one right here, guys, we're going to convert each of these mixed fractions into improper fractions. So we're going to multiply 4 times 3, which is 12. 12 plus 3 is 15/4. Now, next, 5 times 1 is 5. 5 plus 3, that gives you 8 over 5. I'm pausing here just in case you guys have a question. Remember, if you have a question, drop it in the chat box, guys. So now, just like with the previous problem, we're going to cross simplify. 5 goes into 15 3 times. Ooh, let me use a different color. Okay, that's 3. And then 4 goes into 8 2 times. And then you multiply the 3 times the 2. So you end up with 6. There's one like this on the test, guys. Any questions? All right, so guys, moving on to dividing the fractions, very similar to multiplication. When you're dividing your fractions, guys, you want to keep the first fraction, and then you want to multiply by the reciprocal. Reciprocal means to flip the fraction so that the numerator becomes the denominator becomes the numerator. Multiply by the reciprocal of the second fraction. Reciprocal of the second fraction. By the way, guys, you can trick your calculators into doing the fractions for you. I'll show you in a minute how you can type these into your calculator. Some of you have a fraction key on your calculators. Your fraction key is usually A and then a B/C for some of you. There are others that have the fraction key looking something like this. So you have to look at your calculator and see if you have the fraction key in there. If you don't have the fraction key in there, you can trick the calculator into doing the problem. And I'll show you in a minute, okay? So guys, here's an example of a problem. -13 over 20 divided by 39 over 5. So on this one right here, when you're dividing fractions, you want to keep the first fraction. And then you want to change the division to multiplication. And then reciprocate the second fraction. That just means to flip it. And then you go about multiplying, okay? Just like you did with the previous problems. So on this one, guys, again, cross simplify if it's possible. 5 goes into 20, how many times? 4 times. 5 goes into 5 is once. 13 goes into 39 3 times. 13 goes into 13 once. So you multiply straight across. -1 times 1 is -1. And then 4 times 3 gives you 12. And there is your answer, guys. Any questions? No questions? All right, guys. Don't forget to do your attendance if you haven't already done the attendance. Let me see here.
I have a couple of questions on the second homework assignment. If I pull it up real quick, can I give you the example that I'm struggling with?
Okay, we'll do that later after I'm done with the lesson.
Oh, okay.
Then, yeah, you can ask as many questions as you want to. So just hang on to your questions, okay?
Thank you.
Okay, all right, sweetie pie. Now, let me see here. Let me go over here. Do you guys have any more questions on here? The attendance code is, where is it? Hold on, it's in the chat in here somewhere, 2430. 2430, okay? So here comes the next part of this, guys. I want you to go ahead and give this one a try. Let's see how well you do with it. It is 6 3/5 divided by 1 1/10. Okay, give this one a try, guys. Let's see how you do with this. Okay, Gina, did you ever get into My Math Lab? Okay, let me see here. You guys got 6, 6, okay. All right, so Gina, did you get into My Math Lab? Were you able to get in there? All right, guys, so let's go ahead and give it a try. Let's see. 6 3/5 needs to be converted to an improper fraction. So you want to do 5 times 6, which is 30. 30 plus 3 gives you 33/5. That's the first fraction, guys. Now, the second one, 10 times 1 is 10. 10 plus 1 from the numerator gives you 11/10. So next, I'm going to keep the first fraction and I'm going to multiply it by the reciprocal of the second fraction. And now I proceed to simplifying this out. Cross simplify, guys, not cross multiply, cross simplify, as in simplify or reduce, okay? 11 goes into 33 3 times, 5 goes into 10 2 times, and yes, 3 times 2 is 6. So yes, you guys got it. All right, so now I'm gonna move on to the addition and subtraction of fractions. So when it comes to adding or subtracting the rational numbers, guys, pretty much you have 2 different types. You have the types where you have like denominators. The denominators are alike. If the denominators are alike, you wanna go ahead and keep the denominator, and then you want to add or subtract the numerators, and then simplify if possible. Now, here's a quick example. 7/12 minus 5/12. Since the denominators are alike, we keep the denominator of 12, and then we go ahead and subtract. 7 minus 5 leaves us with 2. Now, 2/12, guys, needs to be simplified. Remember in My Math Lab, you must simplify your answers. So this simplifies to 1/6 because both the numerator and denominator are divisible by 2. So this simplifies to 1/6, okay? So when you're in My Math Lab, the answer they are expecting is the 1/6, not the 2/12. Any questions, guys? Okay, yeah, that was straightforward. So let's move on to another one. This next one is 5/16 minus a negative 5/16. Okay, so on this one right here, you will notice we have a minus negative. Minus negative becomes a positive. So we have 5/16 plus 5/16. When you add them together, you get 10/16. Because both 10 and 16 are even, you have to simplify this. You can't leave the answer like this, guys. So reduce the fraction. 10 divided by 2 is 5. 16 divided by 2 is 8. All right, guys. So those are very straightforward. Now, the ones that are a bit more challenging are the ones where the denominators are different. So when you're dealing with fractions that have different denominators, the first step is to go ahead, denominators. The first step is to go ahead and find the LCD. And the LCD stands for the lowest common denominator, guys. So this is going back to what we did last week where we were finding the LCM, the lowest common multiple. So essentially lowest common denominator, lowest common multiple, same thing, guys, okay? Now, once you find the LCD, you got to go back and change the numerators. Change the numerators. And then number 3, once you change your numerators, you're going to keep the denominator, the new denominator, and then add or subtract the numerators. Don't forget, guys, you have to simplify if possible. Simplify if possible. Sometimes you can and sometimes you can't. But for my math lab, guys, you are expected to simplify if possible. You don't even have to be told to simplify. It's just the expectation. You have to simplify the fractions. All right, guys, I'm ready to do an example now. So here comes the example problem. So I'm gonna start with an easy one. For this one right here, I have 3/4 plus 3/20. Guys, remind me to do the calculator bit later on because I forgot to do that with you all. So on this one right here, guys, the denominators are different. You need to find the LCD. The LCD is the same thing we did last week with LCM. So the question is, what is the smallest number that 4 and 20 can go into evenly? If that is not making any sense to you, the other way to do it is like we did last week, guys, okay? So I'm just gonna go ahead and go to the side and show you this. Same thing we did last week, okay? So I take the 4 and I list its prime factors. I take the 20 and I list its prime factors, okay? So we want to circle the like factors. So the LCD consists of all the like factors and any remaining factor, in this case, the 5. So when you multiply them together, you get 20. So 20 is the LCD. So guys, the first fraction has a denominator of 4. To go from 4 to 20, you want to multiply this by 5. You also want to multiply the numerator by 5. So the first fraction will become 15/20. However, the second fraction already has the denominator, so you just keep it. You don't change anything about it. So now that we have like denominators, we keep the denominator and add the numerators together. So 15 plus 3 gives you 18. Now you got to go ahead and simplify this, guys. Both 18 and 20 are even. They're both divisible by 2. So this will simplify to 9/10. And this is the answer you want to plug into my math lab. All right, guys. I think I'm going to give you one now so you can give it a try. Okay, here comes number 2. It's 4/15. Now, I need to say something here because I have many students who do this. 15 times 6, that's the LCD. That is not the least common denominator, guys, the lowest common denominator. No, okay? It works, it will work for you, but that is not the lowest common denominator. You guys go ahead and give this one a try. Let's see what kind of an answer you come up with. And guys, remember you have these powerful calculators that you can use to do these problems, okay? Guys, don't forget, if you haven't done attendance, make sure you do your attendance. All right, remember I like questions, guys, so ask questions. How you guys doing? Okay, let me see what answers you guys got. You go into Blackboard, look for the attendance. Okay, Brianna got 110. All right, Tavion 60, LCD is 30, answer is 110, Jennifer 110, okay. Blackboard will have the attendance, click on the attendance link and type in the code. What was the code again, guys? 2430, I typed it in the chat. Yeah, 2430, it's in the chat in there, okay? Alrighty, guys. So yes, the LCD is definitely 30. Just a recap of how you find the LCD. So you list the prime factors of 6, which is 2 times 3. Prime factors of 15, which is 3 times 5. Circle what they have in common. The LCD consists of the like factor and all the remaining factors, guys. So 2 and 5 are remaining factors. You multiply them together, and that will give you LCD of, yes, 30. So the least common denominator is 30, guys, 30. And so if you change the denominator, you must change the numerators. So for the first fraction, we're going from 15 to 30. To go from 15 to 30, we multiply it by 2. So we do likewise to the numerator. So the numerator becomes 8. For the second fraction, we're going from 6 to 30. From 6 to 30, we want to multiply this by 5, so we do likewise to the numerator. So we get 5 over 30. Now, guys, we're going to go ahead and keep the denominator of 30, subtract 8 minus 5, that's 3. Once again, if the fraction can be simplified, you must simplify it. And there you go. Any questions, guys? All right, now I am going to go into this next problem with you because you will see it on the assignment. I think it might even be on the test. So just in case, guys, pay careful attention to this one. Here it is, 2 squared times 3 squared minus 1 over 2 times 3 squared. Oops, that's a 3 right there. Okay, so very similar question, guys, to what we were doing earlier. Now, the difference here is that they're giving you the denominator in factored form, okay? So I want you to go ahead and compare these two denominators. So you have 2 squared in the first denominator, but you just have 1, 2, okay? Just 2 in the second denominator. You want the denominators to be the same thing. So if this one has 2 squared, this one must also have 2 squared. So in other words, I have to multiply the second fraction by 2. So if I'm multiplying the second fraction by 2 in the denominator, so that both denominators have exactly the same thing, then I'm going to have to multiply the numerator by 2 as well. So now, guys, both fractions have a denominator of 2 squared times 3 squared. So you must make sure the denominators are the same. If they're not the same, you have to do it, guys, okay? So what you do now is you keep the denominator 2 squared times 3 squared, and then you go ahead and combine the numerators together. 5 minus 2 gives you 3 over 2 squared times 3 squared. But wait, we're not done yet, guys, because this needs to be simplified. Now, sometimes it's really hard to see how to simplify this, so I'm going to break it down for you. So in the numerator, we have a 3. In the denominator, we have 3 squared. 3 squared is the same thing as 3 times 3. So in other words, you have a pair of 3's that cancel out. And what are you left with? 1 over 2 squared times 3. So this would be the answer. All right, guys, I'm pausing on this one just in case you have a question. I'm pausing. All right, no questions? Nothing? All right, guys. So if you see this one on the test, you're going to be okay with it? Okay. So I am going to move on to the next part of this, if you're going to be okay with this one. And yes, you will see this problem. Remember, guys, I will be answering all your questions later. So if you don't feel comfortable asking the questions now, I can always answer the questions later. Before we leave the fractions alone, okay, I need to talk about this next word problem. Here's a word problem, guys, okay? So the word problem says, let me see. You know what? Let me pull up the word problem so I can go ahead and give it to you guys exactly like it is, because I don't want to falter on this word problem, especially since it's going to appear, guys, on the test. So I want to make sure I'm giving you the right information right here. So let me go in and take a look so I can find this word problem for you, because I want to make sure you got this one. I am in homework number 2, looking for the word problem, unless somebody knows exactly which one it is. It's the one about the family estate. Oh, I just found it. It's number 8, guys, on the homework number 2. It says a will states that 1/2 of the estate is, you know what? Let me see. No, I'm not going to share it with you. 1/2 of an estate is to be divided among the relatives. Of the remaining estate, a half goes to charity A. What fraction of the estate goes to charity A? Ooh, all right, guys, so let's chat. So if half of the estate is going to the family, what part of the estate will be left over once the family gets its part or its share? What part of it is left over, guys? So if half of it goes to the family, the leftover would be 1/2. Now, all of the 1/2 that is left over, half will go to charity. Half of it will go to charity A. This one is on the test, guys. Half of it goes to charity A. So pretty much you've got a half left over, and then a half of the leftover, 1/2 of the remaining estate is going to go to charity A. So the remaining estate was 1/2, and then you're going to give half of that to charity. So what part of the original estate is the charity going to get? You do 1/2 multiplied by 1/2. So this is going to give you 1/4. Now, this is a nice one, guys, for a nice little picture. Okay, so let's say this box here represents the estate. You take half of it. This half goes to family. So you're left with 1/2. Okay, so you're left with this half right here. That's the other half. Okay, now they want you to take a half of the half that is left over to go ahead and give to charity. So in other words, we're going to break it up into 4 pieces now. So all of the half that was left, you're going to give one part of it, half of it, to charity. So all of the entire estate, what part of it did you give to charity? Well, there's 1, 2, 3, 4 parts, and you only gave this one part away to charity. So this is the part that you gave to charity, guys, 1/4. Okay, I know some people are confused by this one. Typically, I have a lot of students who have a lot of questions about this one. It's definitely going to be on the quiz. So I'm going to do another one like this, guys. So this time, let's say 2/3 of the estate goes to family. 2/3 goes to family. Okay, so if 2/3 goes to family, what part of the estate is left over? 1/3 is left over. 1/3 is left over. Now, all of the 1/3, we're going to give 1/5 to charity. 1/5 is going to go to charity. So now the question is, what part was given to charity? What part of the entire estate was given to charity? So all you're going to do now is to take the 1/5 of the 1/3. By the way, guys, when we talk about the word of in mathematics, the word of means multiplication. So 1/5 of the remaining 1/3 goes to charity. So you're just going to multiply it. What part of the estate, the original estate, goes to charity, 1/15 goes to charity. All right, guys. You're not asking too many questions, so I'm a little concerned. Are you guys doing okay out there?
Yes, ma'am.
I'm doing all right.
Okay. I'll take it. Okay. All right, guys. So,
Excuse me. Can you do one more, please? Because I was having a hard problem doing this one. Just one more with different numbers, please. Thank you.
all right. So here comes another one, guys. So we've got an estate, and it's saying, let me see here, 3/5 goes to the family. If 3/5 goes to the family, what part of the estate is left over? Think about it this way. Here's a box that represents the estate. They cut it up into 5 parts. They take away 1, 2, 3 pieces out for the family. How much of the estate is left over? There's 1, 2 pieces left out of the 5. Okay, that's the remaining estate. Now, out of the remaining estate, the 2/5, this time, let's go ahead and do 1/4 is going to go to charity. If 1/4 is going to charity, what part of the original estate goes to charity? So guys, essentially, once again, you're just simply doing this. 1/4 of the remaining estate, in this case, the remaining estate, sorry, I'm writing the wrong fraction. The remaining estate is actually 2/5. Okay, so 1/4 of the 2/5 is what is going to be given to charity. Remember, I just mentioned of means multiplication. So you're going to multiply 1/4 times 2/5. So we multiply, we get 2/20. However, we have to simplify the fraction. So when you simplify this one, it turns out to be 1/10. I didn't mean for it to turn out to be 1/10 again, but whatever, guys. Okay. And this one is on the first test, guys. Yep. All right, everybody. Let's see how far we can get into this next part right here. And this is going to take us into lesson 5.4. And lesson 5.4 has to do with simplifying radicals, or the rational numbers, guys. Oops, radicals. I'm going to put radicals instead. Simplifying the irrational numbers. The irrational numbers, in this case, they're looking at those radicals. But an irrational number is pretty much a fraction, guys, which becomes a decimal that never ends and never repeats. So an irrational number is a decimal that never ends, never repeats. So if you were to, let's say, put square root of 2 on a calculator, you would get 1.4142. I have it written down. That's why I'm telling you that. That's an irrational number. If you were to do 1/7, you were to plug that into a calculator, you get 0.1428. This decimal never ends, never repeats, so we refer to it as an irrational number. But our goal here, guys, is to simplify radicals, okay? Roots and radicals is what we're talking about in this section right here. And this section, I am going to finish up with it, okay, for tonight. Now, guys, remember, I'm not required to really teach this material to you because this is a hybrid course. The nature of the hybrid course is that you do the work on your own, and when we come together, I go over your questions, but I don't feel comfortable not teaching. That is why I'm choosing this time to teach, okay? And yes, there is a video. Once we're done, it takes about 30 minutes for the video to convert to an MP4, and I will upload it for you. Okay, guys, so in order to simplify the radicals, I'm starting off with a list of the perfect squares. Perfect squares, that's what we call these. What is a perfect square? A perfect square is a number. When you take its square root, that will give you an exact value. For example, if I were to take the square root of 9, What number multiplies itself to give me 9? 3. If I were to take the square root of 36, what number multiplies by itself to give you 36? 6. So any number where you can take its square root, you get an exact value for it. We call it a perfect square. Now, I know you see the list, 1, 4, 9, 16, 25, and so forth and so on. The question is, how is the list generated, guys? It is so easy. All you're doing is taking each natural number and square it. So 1 squared, that's 1. 2 squared, that's 4. 3 squared, that's 9. 4 squared, that's 16, and so forth and so on. So we're taking each number, natural number, and we're squaring it. That's all we're doing here to come up with the perfect squares. Now, why do I put
easy.
this of perfect squares down?
No, for real, it actually does. Wait, do you have that coin G on your phone?
I do, but my phone's dying.
Can I just see?
My phone is dying.
Okay, your mic is on.
19%.
Mm,
But she's on there.
Hi. Your mic is on.
Sorry. Talking
That's
to my
okay.
daughter.
Okay, that's fine. Okay, guys. So, listen. Now, we're going to simplify, okay? In order to be able to simplify these radicals, guys, these are the radicals when you take those square roots, you do not get an exact value for it. However, we can use the perfect squares to help us turn this into a simpler radical. So to simplify the square root of 18, there's a couple ways for you to do it. You can use the perfect squares, or you could use prime factors. So let me go ahead and show you the prime factors because we talked about this last week. So for the prime factors, guys, this is what I do. I prime factor 18. 18 is 2 times 3 times 3. You guys remember that from last week? All right, so every time you find a pair of factors, you take one out. So there's a pair of 3s, you take out a 3, and then the 2, since it's not paired, you leave it under the root. So that's the simplified form of radical 18. Now, additionally, since we already know the perfect squares, we could use the perfect squares to simplify 18. So the perfect squares are 1, 4, 9, 16, and so forth and so on. You ask the question, which one of these perfect squares right here is the largest one that can go into 18 evenly? The largest one that can go into 18 is 9. So we can rewrite 18 as 9 times 2. Since 9 is a perfect square, which means you can take its square root. So you want to take the square root of 9. That gives you 3. And you cannot take the square root of 2 and get an exact value, so it remains under the root. So guys, you got two options when it comes to simplifying radicals. You can do the prime factors, or you can use the perfect squares, okay, to simplify. It's up to you what you choose to do. Now, personally, my preference is using the perfect squares. Why? Because, guys, some of these problems tend to get very long. If you're having to prime factor every number, it's going to be time consuming. That's why I prefer the perfect squares. But guys, there's really no perfect method. How do you know whether to use the perfect squares or whether to go ahead and use prime factoring? Here's how. Here's one reason, okay? One way you will know. If you have to simplify the square root of 300, guys, okay? If you were using prime factors, it would take you more time than using the perfect squares. So for the perfect squares, you know, you got 1, 4, 9. I am going to skip a few here and go to 81 and 100. I would simply ask the question, which one of these perfect squares right here goes into 300 evenly? That would be 100. 100 times what gives me 300? 3. So now I would go ahead and take the square root of 100, which is 10. And then the 3 remains under the root. So there's my simplified form. Now, some of you are saying, well, wait a minute. I don't want to do it this way. I want to prime factor it. You can. Absolutely. If you're going to prime factor 300, it's going to be 10 times 30. 10 is 2 times 5. 30 is 5 times 6. 6 is 2 times 3. So the prime factors for 300 are 2 times 2 times 3 times 5 times 5. Now remember, whenever you find a pair of factors, you take one out. So there's a pair of 2's, you take one out. There's a pair of 5's, you take one out. And then the 3 remains under the root. So now you multiply. The 2 times 5, that's 10 radical 3. Guys, notice, this is the same answer. But which method is easier? Which one is more concise, guys? Which one takes less time? Okay, so it's up to you which method you choose to simplify the radicals. Ultimately, you still get the same answer. All right, so I am going to go ahead and let you guys try a few. Let's see how you do with these, okay? So here's the first one, guys. Square root of 75. All right, you guys try this one. Let's see what you come up with. All right, what'd you guys get? All right, 5 squared root of 3, very good. Okay, so on this one right here, guys, the perfect square that goes into 75 evenly is 25, and 25 times 3 gives you 75. So you go ahead and take the square root of 25, that gives you 5 on the outside, and the 3 remains inside the radical. All right, here's another one, square root of 48. Okay, now 48, ask the same question again. Which one of the perfect squares? 1, 4, 9, 16, 25 goes into 48 evenly. Which one is the largest one? You want to go with the largest one, guys. So what's the answer for this one, guys? 4 squared root of 3. That's good, Alicia. Okay, 48 is 16 times 3. 16 is the perfect square, so you take the square root of 16. That gives you 4, and then your radical 3. Now, next one, 72, guys, the square root of 72. Give this one a try. Okay, which one of the perfect squares is the largest one that can go into 72 evenly? The largest one. Which one is the largest one? All right, guys, hold on a second. I am changing my tip here, which stopped working. All right, so let me go ahead and put this in here. All righty. So, guys, this one is actually 36. I know it's not a part of the list. I ran out of room. That's why I didn't keep writing. Yes, 6 radical 2. Very good, Alicia. So 36 is the largest one that goes into 72 2 times. You take the square root of the 36. So that gives you 6. And then the 2 remains under the root. All right, guys. So hopefully you're feeling a little bit more comfortable with this. And so let me see here. Where am I on time? It's at 7:36. Do you guys want to stop, or do you want me to continue until about 7:45? What do you think, guys? Continue, or do you want me to go ahead and
Continue,
stop?
please.
Okay. All right.
Yeah.
So let me go ahead and continue then. Now, guys, additionally, okay, just like what we've been doing, sometimes they have numbers in front of the radical. And this number in front of the radical is indicating that you're multiplying the radical by the 7. So what you want to do is to simplify the square root of 28. What's the perfect square that goes into 28 evenly? That would be 4. 4 times 7 gives you 28. So now you want to go ahead and take the square root of the 4, which comes out on the outside as 2 outside of the radical. And of course, that 7 remains under the roots. So now you've got these two whole numbers. You multiply these two whole numbers together. So that gives you 14 radical 7. And there you go. So whenever you encounter a number in front of the radical, it means that you're going to multiply whatever the radical simplifies to by that number. One more, guys. Here's one more. Let's say this time I have 3 radical 18, okay? So on this one right here, I have to simplify the radical 18. 9 goes into 18 2 times. Then I want to take the square root of 9, which is 3, and the 2 remains under the root. And then, of course, the 3 times 3 multiplies to 9 radical 2. There you go. All right, guys. Now, let us multiply the radicals together. When it comes to multiplying radicals together, radicals or roots, it doesn't matter what you call them, you want to multiply the roots together. So the roots with the roots, and then the whole numbers with the whole numbers, okay? So whole number with whole number, and then the roots with the roots, okay? Root with root, whole number with whole number. So what in the world am I talking about? Here's what I'm talking about, guys. Let's say we have 3 radical 2 times 5 radical 6. So in the case of this one right here, we got 2 whole numbers. We got the 3, we got the 5. So we multiply them together. We get 15. So we multiply the whole numbers together. Next, we've got the radicals. So we're going to multiply the radicals together. It's 2 roots together. Radical with radical, numbers with numbers, okay? So when you multiply radical 2 times radical 6, you keep the radical, and 2 times 6 gives you 12. Now, big question, guys. Do you just leave it like this? Should you just leave it like this? Should you just leave the answer like this? Are we done with this one? Yes or no? All right, guys. So, nope. We got to simplify the square root of 12. 12 has a perfect square that goes into it evenly. What perfect square goes into 12 evenly? That would be 4. 4 times 3 gives you 12. So then you want to take the square root of 4. The square root of 4, guys, is 2. And then the 3 remains inside the root. So now you multiply 15 times 2. That gives you 30 radical 3. And there you are. Any questions? No? All right, guys. It's a lot. It's a lot to take in. All right. I am going to stop in a few minutes. Okay. Now, let me see here. Let me go ahead and do this. Let's talk about adding, subtracting the radicals, because that one is big on the test. You will see quite a few questions about adding, subtracting radicals. So let's go ahead and talk about that. When it comes to adding or subtracting the radicals, guys, here are some steps. Number 1, simplify the root or radical if possible. Number 2, you want to multiply the coefficients together. You know, that's like what I was just talking about, where you have a number in front of the radical, so multiply the coefficients together. And then number 3, you want to combine like terms. Combine the like terms. All right, guys. So what in the world am I talking about? Here comes the examples, guys. So let's say you have 7 radical 3 plus 6 radical 3. This one is very straightforward. It's already simplified for you. So since the radicals, they both have the same radical, you want to go ahead and keep the radical 3 and combine the coefficients together. So 7 plus 6 gives you 13 radical 3. So in other words, look at it this way, guys. You have 7 radical 3s plus 3 more and plus 6 more radical 3s. Altogether, how many radical 3s do you have? That's all it is, okay? So here comes another example, guys. Number 2, you have 6 radical 17, and you're going to take away 8 radical 17. So what do you have left over? 6 radical 7, take away 8 radical 7, leaves you with negative 2 radical 17. All right, guys, ask me questions if you're not sure what's going on. Anything? Okay, so now, guys, here comes the next example. This is where it's starting to get a little complicated. Number 3, radical 50 minus radical 18. So here you actually have to simplify square root of 50 and square root of 18. 50 is 25 times 2. 18 is 9 times 2. So 25 is a perfect square, 9 is a perfect square. So we take the square root of the perfect squares. So for square root of 25, we get 5. Square root of 9, we get 3. And so now you will notice these are alike, so we combine them. So the answer turns out to be 2 radical 2. All right, guys, any questions? Okay, next. And this is a difficult topic on many students, so I'm doing a few examples. I've got 2 more examples to go, and then I will stop the teaching. All right, guys, so on this one right here, I think this is example 4, okay? Again, you have to simplify the radicals. 12 is 4 times 3. 75 is 25 times 3. You want to go ahead and take the square root of the perfect squares. I like to underline them, guys, so I know exactly what I'm going to take the square root of. So here, I take the square root of 4, that's 2. The 3 remains under the root. And then with the 75, I take the square root of 25, which is 5, and the 3 remains under the root. So now I'm going to multiply the whole numbers, the coefficients together. So I get 8 radical 3 plus 10 radical 3. Now let's add them. So we get 18 radical 3. Okay, 2 more examples. I like questions, guys. You guys aren't asking any questions. I'll be done in a little bit, and then I will be here for your questions, guys. This one is definitely on the test, guys. One very similar to it. When I say these questions are on the test, I mean questions similar to it. I don't mean the exact same thing. Okay, so we've got some fractions in there, guys. So now we're going to simplify the radical 12. Now 12 is 4 times 3, as you saw earlier. 48, the largest perfect square that goes into 48 is 16 times 3. Now we take the square root of the 4, that's 2 radical 3. Then we take the square root of 16, that's 4 radical 3. And now we're going to simplify this, guys. Just to make this easier on you guys, here's what I'm going to do for you. I'm going to put these over 1, so it makes more sense to you guys, okay? I'm going to put them over 1. So essentially, we're multiplying 2 fractions, guys, okay? So let me write them out for you. It's 2 radical 3 over 4 minus 4 radical 3 over 2. Now, guys, These are alike, but the denominators are not the same. So you got to find the LCD. The LCD between 4 and 2 is going to be 4. So the first fraction already has the LCD. So we're just going to keep it. However, the second fraction doesn't have the LCD of 4. To go from 2 to 4, we multiply the denominator by 2. So likewise, we're going to multiply the numerator by 2. So if we multiply the numerator by 2, we get 8 radical 3 over 4. So now that the denominators are the same, we are going to keep the denominator. I'm writing it to the side, guys, here, okay? And we're going to subtract 2 radical 3, take away 8 radical 3, leaves you with negative 6 radical 3. But of course, it's a fraction. If it can be simplified, you must simplify it. And yes, this one can be reduced because both 6 and 4 are divisible by 2. So the answer for this one turns out to be negative 3 radical 3 over 2, guys. So I'm pausing here just in case you guys have a question. Okay. So any questions, guys? Yeah, I'm about to end the recording in a little bit. And then for those of you who didn't want to ask questions earlier, you can start asking your questions. All right, so this one is on the test. I would highlight it, mark it on my notes. And remember, guys, later on tonight, you will be receiving a link to this video. And here's the last problem for tonight, guys, and I will stop the recording. This one is definitely on the test. Okay, you got to simplify this equation. I mean, not equation, simplify the problem. Okay, so on this one, guys, you got to simplify the radicals first. So 75. Now, the other thing I need to say is this, guys. Sometimes I prefer to start with the smaller radicals, like the 12. And the reason why I like starting with the smaller radical is because this would give me some kind of starting point where if I can decipher the 12, I know I can do the other ones, because normally there's a nice hint in there. If 12 is divisible by 3, most likely the other ones are also divisible by 3. So by simplifying the easier problem first, it gives you some nice clues as to what the rest of the problem is going to simplify to. Like the 48, 3 goes into 48. Am I left with a perfect square? Yes. Same thing with 75, guys. Does 3 go into 75? Absolutely. 25 times, and 25 is a perfect square. So you see, by simplifying the smaller number, the easiest number, it helps me to figure out the other ones. So now I like to underline my perfect squares. And so now I'm going to go about taking the square root of all the perfect squares. Square root of 25 is 5. Square root of 4 is 2. Square root of 16 is 4. Okay, so I've taken the square root of all the perfect squares. So now I am going to go ahead and multiply 3 times 5, that's 15 radical 3. And then 2 times 2 is 4 radical 3. And then 2 times 4 gives me 8 radical 3. Now, guys, remember this is the same link we use every Thursday when we get together on Zoom for the remainder of the semester. It doesn't change. All right, guys. So now we're going to combine like terms. So since all of them are like, we're just going to go ahead and add and subtract. So 15 radical 3 plus 4 radical 3 gives you 19 radical 3. And then you subtract 8 radical 3 from that. That leaves you with 11 radical 3. And there you go, guys. Just like that, we are done with the recording for tonight. So I'm going to end the recording here and take